So where does all this energy come from, right, to make an earthquake happen? Well, we know that earthquakes are definitely happening due to fault motion, right? When you have rock literally rubbing on rock, that's going to generate friction, right? So we're going to release that seismic energy, right, as those faults are moving and slipping. So, right, of course, when we think about our faults, we could either be making a new fault or reactivating an old fault. But the one thing to remember is once the ground's been broken, right, once that lithospheric plate has been broken, it's always going to be a permanent zone of weakness. So we have to realize that our plates, these faults, aren't in constant motion 24 hours a day, nor are they smooth, right? When we looked at faults, right, if here's the earth and we kind of talked about a fault looking like this, I drew it smooth, right? They're really not smooth, right? Rocks don't break nice and smooth. Instead, they tend to look like this, right? So you can see it's got these asperities, right? So really, things kind of move in this jerky stop and start motion, right? Because they've got to build up enough energy to work over these humps, right, and move. So what we tend to see is that we've got this kind of stop and go motion along our faults. So we can kind of explain that by stick and slip, which is a pretty good analogy if you take a look at this over here. So let's say we're pulling a weight on a spring, right? That weight isn't going to move until we really stretch out the spring, and then, of course, the weight moves. Well, the weight doesn't continue to move. You have to stretch out the spring again. So we have this constant stick and slip and stick and slip motion. And that's exactly how our faults work as they move over these bumps along those fractures. Can faults move without earthquakes? Well, kind of, right? Well, we know faulting itself is a brittle deformation. This means this is generally happening up at the surface where our rocks are cold and tend to break. If we look deeper down inside the earth, right, the lower levels of the lithosphere, our rocks are hotter. Those rocks are going to behave ductily, just like you see in this picture, meaning they've been bent. They're not really breaking. So that ductile deformation does not generate an earthquake. And what we see is, in general, about 15 to 20 kilometers below the surface is where we start to see that ductile behavior. So that means our rocks are going to be hot. So, in general, right, if we take a look at our earthquakes, sometimes our major earthquakes are preceded by smaller earthquakes, and we call those foreshocks. So sometimes foreshocks happen, but they definitely don't happen all the time. And this is what makes predicting earthquakes kind of tricky because it's not always present, right? But we always pretty much have aftershocks. So aftershocks are the smaller earthquakes that happen after the main event. And basically what we have is, right, is remember when our earthquake happens, right, when that movement happens, we're getting that movement at one pinpoint inside the earth. So the rest of the plate has to adjust to that movement. And that adjustment tends to be those aftershocks.